couple pilots from San Diego to go through a general or basic weather overview of what you might look for in any given day. This is the screen we start off with. This is surface analysis, and if you want to talk about what you're looking for here.
Yeah, so surface analysis is your big picture. All right, so this is going to show you where your high pressures are at, where your lows are at, your millibar line, so you can see what the general barometric pressure of your area is. You can see if there's a trough nearby, or you can see if there's a front coming. And when you look at this, you should be able to kind of get an idea of what direction the wind should be coming from and going towards, and maybe have a little bit of some backfill on what the thermals might be feeling like for the day. So, if it's a lower pressure, you might get those softer, wider, nicer thermals. But if we're dealing with a little more higher pressure, then you're going to get something a little sharper on the edge, maybe a little more bubbly, maybe a little more bullety. But yeah, this is just one of the building blocks, baseline pieces for your weather model. And as you go through the weather situation daily, you're building a model in your head. So that should be the fundamental thing you're trying to do.
And something you've been saying to me is like, hey, weather's a black art. Like, there's not a perfect way to do it. We just get as much data as we can or we're comfortable with. You find the way that works for you, and you go from there. So this is where you start, and then I'm clicking over to my next tab. And just as an admin aside, I've got my whole little folder here, weather and planning, and this is how I go down it. So you may want to set up yours the same way, but we'll put all the links for this in the discussion or the description notes. So this is your second tab.
Yep, second tab, and this is the National Weather Service area discussion for San Diego. They do these for every area all around the states, and this is the real big brained meteorologists that have degrees, and they're looking at all the models, and this is their general consensus of what they think today is going to be, tomorrow, in the next few days. There's a lot of really techie meteorological terms in here. Some of them are highlighted in blue, and you can click on those little hyperlinks, and they'll go to another page and maybe give you a definition of what's going on. And feel free to dig in and read this. When I do weather, I read it almost daily, and this is one of the cornerstones for me as to what's coming up. And they will tune in on certain things. So like if it's a high wind situation, or if there's rain coming, they'll definitely highlight those big pieces for you. They're not writing this so much to a pilot, except for down here at the bottom. They will give you a little bit of an aviation piece, and that's just for motor pilots. That's not for us, so they're not talking about thermal strengths and whatnot, but they're mostly talking about visibility and wind strengths.
Cool. So from here, the next thing you'll go to is Skew T.
Yep, so Skew T, this is one of our actual pieces of information. So all throughout the United States, they send up these weather balloons. They do one at 6 in the evening and one at 6 in the morning. So if you look at the bottom there, this is the 12 Zulu, so this is the morning one. And then the 00Z, that is the one that is in the evening. So we always want the 12 Zulu, that's the morning one. And what you'll find on here, on the far right side, you have the wind as it goes up through altitude. And those barbs show you what direction it's coming from. So we'll just go over these ones at the bottom here. So that's showing that the wind is coming from the northeast. And if you look up the wind barbs, you can see what they mean. But I won't go into the strengths. You can find that pretty easy. Next one we'll go over is this red line. As that balloon goes up, it's sensing the temperature of the air, right? And if the line continues to go to the left, it's cooling. When it shoots back to the right, that's when it's warming. So that first little tick there at the bottom, that's our first little inversion we have to worry about. And then it cools again, then another inversion. So that's what that one does. That's giving us temperature. The next most important line is this blue one to the left, and that shows us humidity. And where these two connect, like up at the top, is where you're going to get cloud formation. So that's really high up in the atmosphere. On the left, this is your pressure readings. So the one that I look at actually will show me altitudes, but this is the pressure altitudes. But anyways, the 150, that's really high up, 30,000, 40,000 feet. And when we look at the sight cameras here in a little bit, the webcams, you'll actually see that we do have some cirrus today. And that's what you're seeing right there. sometimes you'll see them connecting down at the bottom, and usually that is like a ground-based cumulus type cloud.
Yep.
One of the interesting things you can do with this chart, as was just noticed, when the lines jog back to the right, you're looking at an inversion. So often in trying to decide what site you want to pick a launch that is above an inversion and gives you enough altitude to have some flyable altitude before you get to the next inversion.
Dig it. Cool. Jetstream?
Yeah, so Jetstream. And this is something that a friend of mine keyed me in on just a little while ago, and I started factoring it more into my site calling. And what I was told was that if the Jetstream is over you, that it's a real strong current up there, and some of that turbulence will find its way down through the atmosphere. So if you find a day that you're flying and there's just some unexpected rowdiness and craziness going on, if you go back and look at this, you might find that the Jetstream was either near us or directly over us. And even though it's several thousand feet above any air that we're going to be in, that stuff reverberates down, is what I was told.
Cool. And typically the Jetstream would be much further north. Today is January 26, 2019, so we're seeing some stuff that's odd for us here in San Diego.
In general, weather descends through the day, not just the Jetstream. So if you see high winds at altitude early in the day, they are probably going to work their way down to our flying altitudes in the afternoon.
Cool. All right, next up is the cams. So we talked back here about the Skew T and where you're going to see the clouds cirrus up high. Now we're looking at the SDHGPA weather cams. And yeah, talk through it.
Yeah, so this is another part. You can find this on the club website. And like I said, this is another piece that's actual real-time stuff. It's not a model. It's not a simulation. This is real stuff that's going on. And what I use this for mostly is looking for clouds. So if the National Weather Service area discussion says there's going to be high clouds, I can look on here and see it. We can also look on the weather models to see if it's there. Another big piece is the low-lying clouds. So some kind of surface level cumulus cloud. If it's obscuring the launch or blocking some sun, this will show where those clouds are at really well. Other than that, there's not a whole lot that I get from this.
Okay. One thing that you had pointed out today when you were looking at it was it may be hard to see, but there's a bunch of dust coming through here.
Yeah. So that's Palomar High Point looking north to Aguanga. And this dusty area, I think that's where Anza's at, and it looks like it's pretty windy there. So it's tearing up the ground. Got some dust raising up.
Cool. So just getting some extra cues.
Yeah, and you could also maybe see a fire that's happening. This is just a really good thing to actually let you look around. You don't have to go outside and look at the sky. You can do it from your bedroom. When you're doing weather. So it's nice.
It gives you a good feel to match what you're seeing in the models with what you're seeing with your own two eyes. And really, once you've picked a site and you've been doing this for a while, what you see with your own two eyes will become the more important, because you look at these high clouds and you're like, I'm thinking that doesn't look good for flying today.
Dig it. Next up, got the MesoWest. So this is actual winds.
Yep. So this is free site, actual winds, and this is good just to see what's going on big picture. There's so many wind indicators, and this is actually something that I use in flight occasionally as well if I have reception. Like if you're flying a convergence line or if you're getting ready to cross Banning Pass or something. So this is one of the sites that I'll pull up and I'll see what's going on. So it's really good functionally in the air. It does take a bit of bandwidth, but it works. But yeah, this is just another actual thing. So I look at this a lot of times during the day. So I've already decided where I'm going to go, and I'm just deciding when it's going to get strong enough, when's a good period. So yeah.
Cool. And just clicking on any of these gives you
actual.
the station and what's going on there. So it's blowing out of the east, northwest, east of Blossom. We're not flying Blossom today.
No.
I would add that you pick 3 or 4 sites that you check regularly on this so that you get a baseline. Lions Peak has always been a good one for me because it's in clear air. A lot of the sites that are down low or in town or whatever are going to give you weird readings a lot of the times that aren't representative of the actual wind.
Lions Peak is down here somewhere?
Yeah, it's down by the border.
Yeah, okay.
Otay Mountain's another good one.
Yeah. Cool.
Yeah, and there's one other interesting piece that I use on here, and that is if you go onto the left side, one of these overlays, you can actually see dew point, I believe. And what I use that for,
The DP.
or it might be relative humidity.
Okay.
Try that one. But anyways, sometimes at Blossom we'll have cloud cover, like a May gray, June gloom situation, and the relative humidity will be 100% if it's obscured by cloud before it's had any sun. As soon as the sun hits the ground, that relative humidity will start dropping from 100 and it'll go like 98, 99, and within an hour it'll be down to like the 80s. So as just a idea of has the site gotten any sun yet, I like to look at that. That way you don't need a webcam or anything. You can just tell if it's already had sun.
Got it. Oh,
Yep.
Good one. Cool. Sweet. Next thing is this is where I was starting before I had this little mini class. So this is our local Windgrams, and I usually focus on the south. But you want to talk us through kind of what you're looking at here?
Yeah. So Windgrams, they're powered off the RASP table, so they are fed off the RASP. You want to make sure that you're looking at the most current one. So sometimes you have to hit the little force of refresh. And then, so this is still for Friday. Obviously, we're on Saturday, so it's one day off. But yeah, you want to make sure you refresh so you're looking at good data. Sometimes they don't update regularly. So they're okay. They're not awesome. And sometimes you look at the RASP table, and the RASP will actually show you a little bit different information because the most current model is shown on the RASP, and these just don't update as frequently. So I use these just as a primer. Like I look at the sites, and if one of them looks exceptionally well on the Windgram, then I key into that and I dig deeper on the actual models to see what's going on. So it's just a real good visual of showing you what might be good.
Dig it. Let's do the RASP.
Yep, so let me go to the RASP, and whenever you're using the RASP, we always want to make sure that the model's updated. So I always click on Status Report, and you can see that the south model, the run started at 3:28 this morning, but it has not updated. So usually what happens is the south model will update at about 8 to 8:30 in the morning. So you want to use the south in the morning, and then around 10 or so, the entire model will update. Obviously, for some reason, it's not working today, so you'd be looking at invalid information. You look at the last time that the south model updated, which might have been, upload complete 7:56 yesterday morning, which is when it normally updates, around 8 o'clock in the morning. So yeah, so we want to make sure it's updated, and then we click on our model, which is south. We select today. And then my first thing I like to look at is winds, so surface winds at 10 meters above the ground, and then you can click through the hours. I also like to darken up the shading, so I'll slide that puppy over. That makes it a little bit easier to see. And you're just looking at surface winds, where they're at, direction they're coming from, and the strength. So today you can see tons of east wind, really strong. Another thing to keep in mind is that this is in knots. Not miles per hour, not kilometers, so nautical miles a little longer than a regular mile. So even though it says maybe 10 knots, it's probably more like 12 miles an hour. So that can fool you a little bit on the strength. Next thing I like to look at is the height of critical lift, which is how high the thermal is going to take me. After that, I might look at the clouds, so CU cloud base, to see if there's going to be any clouds in the area. And then the last thing would be thermal strength for me, so thermal updraft velocity. And like I said, you're just putting all these pieces in your head, and you're kind of deciding on a few sites, and then you dig into these programs or these models and see if it's really what you want to be working with. The last thing I would do would be like OD. So if it's a frontal situation. So if we're flying like frontal conditions, or if we're flying monsoonal stuff in the middle of summer, or just the convergence line, Horse Laguna, OD is a situation for those, and we want to see if it's going to happen. If so, where it's going to be at.
Cool.
And that's pretty much the extent on the RASP.
Dig it. And then the last thing is, if you want to pay for XC Skies, it's $40 a year. We will cruise over and see what we've got there.
Yeah. So RASP I find is really good for midsummer, but So fall and early spring, it's not so good, or in the winter. So you'll miss a lot of good days. Whereas XC Skies kicks up all the stuff in the winter and the summer. So this is more of a package deal. Obviously, there's more models on here. And of the models on here that I like to use, the NAM 3 and the HRR 3. That's the two that I like for this area. And if you look at these, they only show you today and maybe one day out for both of those models. So this works a little better day of or day before, whereas RASP will show you like 3 days out. If you did want to look on here and see something farther out, you can click on the GFS and you can see it populates all the way till Wednesday, but the GFS really isn't super accurate. When you are on here, obviously you want to make sure your time zone's set correctly. So we are in -7. And then on the left side, you'll see there's just an immense amount of information you can get. Surface winds, lift above ground, XE potential, cloud covers, just everything. This site's really well done, and it's really worth that $40 if you're trying to maximize what you can do with the day or just trying to be safe. And this site, the RASP, that's good for SoCal, but this site is good worldwide. So if you're a traveler, you probably want to have this paid for and be using it. Get familiarized with it.
Cool. That's it. Yeah, weather's one of the biggest things for all of us as a safety factor, so all this stuff's worth paying attention to. Cool. Thanks for watching.